Hello, class. Today, what we are going to talk about is congruent polygons. Now, two polygons are congruent if and only if all pairs of corresponding parts are congruent. What does that mean? Well, you see here in triangle ABC and triangle DEF that A and D are congruent. Angle C is congruent to angle F. Angle B is congruent to angle E. These angles correspond with each other. I could take this triangle and I could do a reflection with it and then a little bit of a rotation, and they would match up perfectly. This angle would match up with that angle. This side angle would match with that one. They're corresponding. Also notice, though, that not only do the angles are the angles congruent, but also the sides are congruent, corresponding sides. So side BC is congruent to side EF. Side AB is congruent to side ED, and side CA is congruent to side FD. So the corresponding angles are all congruent, the corresponding sides are all congruent. Okay, and so since all of these pieces are congruent, then the figures are congruent. So all the pieces are congruent. Okay, if you had some, a square that had, a quadrilateral where three of the sides matched three of the sides of the other one, but that one side didn't match up, then it's no good. It's not congruent. Okay, so if you have one little bitty thing wrong, then the whole thing is not congruent. It's no good. All right. Now, when you write a congruent statement for two polygons, always list the corresponding vertices in the same order. All right. So you can write them more than one way. You just have to put them in the same order. So, for example, here, triangle ABC and triangle DEF, when A corresponds with D, so we need A to correspond with D. All right. We could write it this way. We could say BCA and EFD, but still we see A corresponds with D. They're both at the end. Here they're both at the beginning. All right. B corresponds with E, so here B is in the middle and E is in the middle. Or we could rewrite it, we could put B in the beginning and E at the beginning, and that's fine because the corresponding angles are all, the corresponding vertices are all in the same order. Here C corresponds with F, and here C right there in the middle still corresponds with F right there in the middle. All right. And so that's very important. That lets us know, even if we don't have a picture of the two figures, we know which two vertices go together. And by extension, since we know which vertices go together, we also know which sides go together, even if we can't see it, because we can see the side AB is going to go with side DE. Over here, segment CA is going to correspond with segment FD because they're in the same position. And so we know those two go together and those two are going to be congruent to each other, even if we can't see the picture. Okay. And this right here, which says triangle BCA is congruent to triangle EFD, that is a congruent statement. So if you have a homework assignment or something that says write a congruent statement, that just means say this figure is congruent to that figure. That's all it wants. Okay. Something like that. Just make sure that your corresponding vertices are matched up. They're in the right order. Okay. Now, we do have some properties of triangle congruence. These should actually be very familiar because we have already talked about the reflexive property, the symmetric property, and the transitive property before. All right? We talked about them when we dealt with the properties of equality. We talked about them when we dealt with congruent segments and congruent angles. It also works for congruent triangles. All right? So for any triangle ABC, ABC is going to be congruent to ABC. Believe it or not, a triangle is congruent to itself. Go figure. Now, symmetric property. If triangle ABC is congruent to triangle DEF, then triangle DEF is also congruent to triangle ABC. All right. Just like we've dealt with before, we saw that if x equals 5, then 5 equals x. Same kind of thing. Symmetric property. You're just changing the order around. Transitive property. If triangle ABC is congruent to triangle DEF, and DEF is congruent to triangle JKL, then ABC is congruent to triangle JKL. just like we had on the transitive property. If A equals B and B equals C, then A equals C. Right? Okay. We do have one theorem that we're going to add here, and this is the third angles theorem. What the third angles theorem says, that if you have two triangles and two angles in one triangle are congruent to two angles in the other triangle, then that third angle must also be congruent. Okay, so since B is congruent to angle E and angle A is congruent to angle D, what that means is angle C must also be congruent to angle F. And if you think about this, again, put this together with the triangle sum theorem, we know that all three of these angles have to add up to 180, and all three of these angles have to add up to 180. All right? So if we subtract A and B from 180, we're going to be left with whatever C is, right? Well, if E and D are the same as A and B, then we subtract these from 180, we'll be left with the same thing that we were left with here. And so F and C also have to be congruent. Now, does that mean that the triangles are congruent? No. Remember, for the triangles to be congruent, not only the angles have to match up, but also the sides. Everything has to match. And if you don't have everything matching, then the triangles may or may not be congruent. You don't know. Just because the angles match up does not mean that the triangles match up. All this means is that if you have two angles congruent, then the third angle is also congruent. It does not mean that if you have two angles congruent, then the triangles are congruent. That's not what this means. It just means that that third angle is also going to match. Okay? All right. So let's take a look at a couple of examples here. Let's see what we can do with this. All right. So 1 and 2. What do we got here? Identify all pairs of congruent corresponding parts, then write another congruent statement for the polygon. Okay, so we want to identify, it tells us triangle PQR is congruent to triangle ST. So the triangles are congruent. So what that means is that even though the segments, the sides, are not marked as congruent, they're congruent because the triangles are congruent. Now, it wants us to identify all pairs of congruent corresponding parts. So this is going to be just a little bit tedious, but it's not terrible. It's not difficult. It's just going to take a little bit of time to write it all out. So let's see. First things first, let's take care of the angles because those are easy to see. We see that U is congruent to R. They have the same little tick marks on them, right? Also, we can see that U and R are both in the third position there, so they're congruent. So we need to say that angle U is congruent to angle R. Okay, what else do we know is congruent? Well, Q and T, they both have two little arcs there showing congruence. And if you notice, Q and T are both in the same position. They're both in that middle position there. So angle Q is congruent to angle T. And I just mixed these up, but that doesn't matter. It's the symmetric property, right? If angle Q is congruent to angle T, then angle T is congruent to angle U, and it's fine. Okay, so then we have P and S. So angle P is congruent to angle S. There's all of my angles, but it wants all pairs of corresponding parts, which means we also have to talk about the sides. Okay, so the question here becomes which sides are corresponding to each other, right? Well, we could look at this. Let's see here. PQ would correspond to which side? Well, it seems to be the shortest, so we'd probably go with the shortest over here. It's got to go the shortest. So that would be S and T, right? Better way to look, well, P has 3 tick marks, S has 3 tick marks, Q has 2 tick marks, T has 2 tick marks, so it's in between the one that has 3 and 2, right? Or we could just look up here. Let's see. P and Q, those are the first 2 letters. So over here, I want the first 2 letters. So P, segment PQ, is congruent to segment ST. Just take the first 2 letters and the first 2 letters. All you got to do. So QR, my next 2 letters, segment QR, got to put the little segment bar above it, is congruent to segment, let's see the next 2 letters, that would be TU. And then we need the last one to have 3 sides here. So segment RP is congruent to segment US. US. And that's it. Not too bad. Okay, so that is all 6 of my corresponding parts. 3 angles, 3 sides. That's all of my parts there. It wants another congruent statement. So it wants us to say that these 2 triangles are congruent to each other, but it wants us to do that in a way other than what is right here. Okay? So that just means we're going to say the 2 triangles are congruent. We're just not going to have the letters in this order. So triangle, instead of saying PQR, I could say RPQ. Why not? RPQ is congruent to triangle. Let's see, what goes with R? U goes with R. They have the same thing. So U, and then I had P. P matches up with S because they have 3 little arcs there. So US, and then Q is going to match up with T. And there it is. That is my new congruent statement. Do I have to do that? No. I could have called it RQP. I could have called it QRP, QPR. It doesn't matter. I just can't call it that because it's onto something different. So what I would like you to do, pause the video, workout number 2, write down all pairs of corresponding congruent parts, and then give me another congruent statement for the polygons. All right? So pause the video, work that out, and then come back, check your work. Okay, you're back. Let's take a look at what we got. Okay, so here we have quadrilaterals, which means we're going to have a bit more work to do because we have 4 sides and 4 angles. So that means we're going to have a total of 8 things. So I'm just going to take them right here. I'm not really even going to look down here. I don't need it because I've got these and they're in the right order. So let's see. I don't have a whole lot of room here, do I? Okay. So angles first. Angle A is congruent to angle. Let's see. That was the first one and the first one. So E. Angle B is our second one, and angle F is the second one. So E is congruent to F. Angle C is the third one, so that is going to be congruent to angle G, the third one over here. Angle G. And angle D is the last one on the first figure, and so angle H is the last one on the second figure, and so those are congruent to each other. And I'm not really even looking. I could look at the picture, but I don't need it because I've got the figures, the congruent statement. That's why we have congruent statements, so I don't have to look at the figure if I don't want to. Okay, so now let's do the segments. See, so AB. So segment AB, my first 2 vertices on the first one, and that goes with EF, the first 2 vertices on the second one. So segment EF. Next, we have BC. So segment BC is congruent with segment, and the second 2 here would be FG. FG. Next, we have segment CD. Segment CD, got to put the bar on top of it. Congruent to segment, let's see, those are the last 2 here, so we need the last 2 here, that'll be GH. GH. And then finally, I have segment DA, which is congruent with segment HE. Like so. All right. And that's all it is. You just take them in order, take them in pairs. Do we have to do them in that order? No, we don't have to do them in that order. I could just as easily call this segment AD, segment DC. It doesn't matter. But if I change this around and call this segment AD, then I need to change this around and call this segment EH. All right? So, not a big deal. Just make sure you have them in the same order. Now we need a congruent statement, something other than that. So let's just see here. I'll start with C. C, and then we'll go this way. So we'll go backwards. So C, B, A, D will be congruent with, let's see, C matched up with G, B matches up with F, A matches up with E, and D matches up with H. C, B, A, D will match up with G, F, E, H. And there we go. There's my other congruent statement. You could have something different here. Just make sure that whatever you have right here, Again, it goes around the polygon. You can't cut across the polygon. You can't call it CADB and jump across the polygon. You got to go around the lake, not through the lake. Right? And then make sure that they match up corresponding. C is with G, B is with F, A is with E, and D is with H. All right? Okay, so that is super simple stuff. Not a big deal there. Let's take a look at this next little bit. In exercises 3 and 4, we want to find the value of x and y. Okay, so on number 3, it tells us that triangle XYZ is congruent to triangle RST. All right, so there's our triangles. And we need to find x and y. So what is x? X is here. 2x minus 20 is the measure of angle y. And we've got the side here is 15 centimeters. We've got this side is 3y plus 9 centimeters. And angle S is 30 centimeters. Well, looking at this, they're not marked that way. I don't know which angle is congruent with y by looking at the picture. However, from my congruent statement, I see y is my middle vertex and S is my middle vertex, which means that angle y is congruent to angle S. I get that from the congruent statement, which means 2x minus 20 is congruent to the 30-degree angle. And so the measures equal. Since the angles are congruent, the measures are going to be equal. And so to find x, what I can do is I could just take 2x minus 20 and set that equal to 30 degrees. I'm going to work this out. You got to add 20 to both sides, plus 20. And so now I have 2x equals 50, divide by 2, and x equals 25. All right, so there is, yeah, that's all I want to say, just x. Well, and y, but I don't have to do anything with the x. I don't have to plug it back in or anything. All right, so there is x. Now let's find y. Y is right here in my segment ST, which means that is going to match. I've got a couple little tick marks here, but it's going to be congruent. So apparently we have isosceles triangles. Whatever, it doesn't matter. All I really need to know is that ST is congruent to, well, it says it's ST is congruent to YZ, but YZ is congruent to XZ. So these two match and that one matches. So by the transitive property, since ST matches with YZ and YZ is congruent to XZ, then XZ is congruent to ST. And so I can set those equal to each other. All right. So 3y plus 9 equals 15 centimeters. Subtract 9 from both sides. And I end up with 3y equals, let's see, 15 minus 9 is 6. Divide by 3. And I have y equals 2. All right. So not too bad. Pretty easy stuff, really. I'd like you to pause the video again, and this time I want you to work out number 4. Okay, so let's see how you did with number 4. We have these two polygons. We are told that they are congruent to each other. And let's see, x is over here in vertex A. A matches up with E. So E is 108 degrees. So I can set those two equal to each other. So 60 plus 8x equals 108 degrees. I'm going to subtract that 60 out from both sides. You know what, I'm going to go ahead and draw my line out there. It helps. All right, and so now I have 8x equals 108 minus 60 is 48. Divided by 8. And x is equal to 48 divided by 8 is 7. 7? No, sorry, 6. 6. There we go. X is equal to 6. All right, now let's take a look at y. Where is y? Y is right here in angle G. Angle G, looking at that. That's the third one, so it matches up with the third one, so it's C. G matches with C. Those two are congruent, which means the angles are equal. So 8y minus, oh, that's fun. I've got an x in it. Minus 3x equals 62 degrees. Well, this is a problem because I've got an x. What is, oh, wait, there it is. X is 6. So I can just plug that in. That'll help. 8y minus 3 times 6 equals, what was it, 62. 62. 3 times 6 is 18, so 8y minus 18 equals 62. And I gotta get y by itself, so plus 18, my line down there. So 8y equals 2 plus 8 is 0, okay, my 1, and that will be 80 divided by 8. Running out of room, but fortunately I'm at the end. Y equals 10. And there it is. All right, so that one was a little bit more involved, but still not bad, right? Not too bad. Okay, so now let's take a look at the rest of this. Number 5, where'd number 5 go? There it is, number 5. We need instructions. What are we doing with this? Okay, there it is. And there we go. And 5 and 6, we need to show that the two polygons are congruent and explain our reasoning. How do you know they're congruent? Now, if you remember, we said for two figures to be congruent, they have to have all corresponding parts congruent. So we have triangles here, so we have 3 sides, we have 3 angles. We need 6 different things shown to be congruent. Let's just start listing what we have. Angle A is congruent to angle C. Those are marked. Yeah, we'll just do it right here. All right. Angle A is congruent to angle C. What else is marked on this? Let's see, D. So AD, segment AD is congruent to segment DC. Those are marked. Segment AD is congruent to segment, what was it? AD and CD. Put these in the same order too. Since A corresponds with C, call this AD and CD, not AD and DC. We want those in the same order. What else is marked congruent? Here we got little tick marks. So segment AB is going to correspond with segment CB. It'll make it congruent, sorry. So segment AB is congruent to segment CB. And nothing else is actually marked as being congruent, is it? That's it. We have to explain our reasoning. How do we know this? We know all of this because it is given to us. I'm going to put this in like a 2-column proof kind of thing. I'm going to get into that stuff. That's going to be a pain. Well, anyways, this is given. Given. I need to move this over. Okay. What else do I know? I know, well, they're not marked congruent, but ADB and angle CDB, these are both right angles. So I know those are congruent because all right angles are congruent. That's the right angle congruence there. So I'm going to go ahead and mark those. Angle ADB is congruent to angle CDB. Even though they're not actually marked congruent, I know they are because of the right angle's congruence there. So right angle congruence. Right angle congruence. Congruence. There. So that gets me 4 of my 6 that I need. What else? Right here, this is a little weird. Okay, but segment DB in triangle ADB is going to be congruent to segment DB in triangle CDB. Why? How do we know that segment DB is congruent to segment DB? Well, because of the reflexive property. And you're like, wait, we have to actually say that segment DB is congruent to segment DB? Yep, we do. It's one of those things, it's kind of silly, but This is in both triangles, and so we have to say that the segment in this triangle is congruent to the segment in that triangle. So, yep, segment DB is congruent to segment DB, and this is reflexive property. I told y'all before we were going to use this a lot, and so here it is. This is the first time we're actually using it, reflexive property. And the last thing we need another angle, right? One angle, two angles. Yep, we need another angle. We need angle, right here. We need angle ABD and angle CBD. And I've got nothing. How do we do this? What do we do? Wait. We do remember we've got two angles congruent, right? If we have two angles in one triangle congruent to two angles in the other triangle, that means that those third angles are also congruent. This was the third angle congruence theorem that we had over here on the front of the page, right? The third angles theorem. All right, so we can do this. We got this. All right. Here we go. So 4, we have that angle ABD is congruent to angle, match these up here. ABD. So angle CBD because of the third angles theorem. Third angles theorem. All right. So now I've got 1, 2, 3 angles. I've got 1, 2, 3 sides. So there it is. The triangles are congruent. So triangle ABD is congruent to, make sure I match this up. A went with C. B went with B. And D went with D. There we go. So triangle ABD is congruent to triangle CBD. How do I know? This is the definition of congruent triangles. Definition of congruence. Definition of congruence. Congruence. Yeah, spelling is not my strong suit. So there it is. A little bit tedious, but not terrible, not terrible. I would like you now to do number 6. Okay, again, pause the video, work out number 6, and very important, explain each one. How do you know? Is it marked that way? Do I have some theorem that backs it up? How do you know that each of these sides, each of these angles is congruent to the other angle or the other side? And get all 6 sets to match up. Okay, let's see how you did. First, let's start with everything that is marked as being congruent, or given information. I'm gonna give me this one. There we go. Keep this stuff separate, and I'll change colors. That will help too. Okay, so we know that, let's see here, segment AD is congruent to, which one is that? This one here. And looking at that, AD is going to go with CB. Segment CB. We know that, let's see here, DC, segment DC is congruent to segment, that'll be BA. I know that, let's see, that's the only segments that are marked. I've got some angles though. All right, so angle, let's see, A is my vertex, so DAC, saying angle DAC is congruent to angle, let's see, that would be this angle here, so that would be BCA, congruent to say angle, what did I say? Is it BCA? That's right. And then the other angle, this one here, so that would be DCA, angle DCA is congruent to angle and BAC, to angle BAC. How do I know this? I know this because it was given to me. I got to explain it. It's marked on the diagram, and you can put it like that too, marked on the diagram. So this is given. Okay, number 1. Next thing, what else do I know? I know that, hey, this is real easy. We can pick that one up. Segment AC is congruent to segment, not to segment AC. All right? Because this vertex doesn't match up with this vertex. That A in this triangle matches up with C in that triangle. So instead of saying segment AC is congruent to segment AC, what we're going to say is segment AC is congruent to segment CA. Why? Because they're the same segment. That's reflexive property. So 2, this is reflexive. I'm not going to be able to fit this in there. I think reflexive. That is hot. Okay, so I've got all 3 of my sides. I now need one more angle. All right, and that would be D and B. And how do I know that angle D is congruent to angle B? Well, because the other 2 angles were congruent. And the third angle theorem says if 2 angles in one are congruent to 2 angles of the other, then that third angle is also going to be congruent. So angle D is congruent to angle B because of the third angles theorem. Third angles theorem. All right. And since I have all of these matching up, I can now say that triangle ABC is congruent to triangle C. A matches up with ABC, this one matches up with C over there. So CB matches up with D, and then C matches up with A. All right. There we go. I can now say that, and that's definition of congruence, whatever. We've said that they're all there. And so I've now explained how they all work. Oh my goodness, and you can't read that very much because it's off the screen. There it is. All right. So not terrible, not terrible. A little tedious, yes, but it's not bad. And you see, we actually are using that reflexive property like I told you we were earlier on in the year. Okay, last 2. Let's see what we got. Okay, so it says to find the measure of angle 1. That's all we got to do. Just find the measure of angle 1. Okay, we can do that. Maybe we can do that. Let's see here. We've got triangle ABC. We've got triangle DCB. We know that this angle is 33 degrees. It's congruent to that angle, but I'm not interested in that. I'm interested in this angle down here. All right. So, well, this is a right angle. So if I know what this angle is, if I know what x is, then I can subtract whatever x is from 1 and that x from 90 because it's a right angle, and that'll give me angle 1. Okay, so how do I find that? Don't know. I'd have no information at all about triangle ABC. I do have some information about triangle DBC, though. And if you look, I have 2 angles. That angle is congruent, and these are right angles, so they're congruent. So I have 2 angles in triangle ABC congruent to 2 angles in triangle DBC. And so what that means is that this angle right here is congruent to this angle right here, because if 2 of the angles match up, the third angle is also going to match up. And I know that this is a right angle. I've got right triangles, which means the acute angles of the right triangle are complementary. That's the right angles, the triangle sum corollary to the triangle sum theorem. So let's see here. We've got 90 degrees minus 33 degrees equals, that would be 7, but that, so that would be 57 degrees. So I know this angle is 57 degrees, and if that one's 57, this one's 57. And now I can, that's nifty. So I'm going to take my right angle right here, 90 degrees, minus this 57 degrees, and that gives me 33 degrees. That's angle 1. So angle 1 is 33 degrees. All right, so not too bad. All right, so there's that, and we're going to do something similar. Notice these triangles are not congruent. We don't care if they're congruent. We're not looking for that. We are interested in the angles. All right. So it doesn't matter if these triangles are congruent or not. We're looking for the angles, and we'll know are the angles congruent. And so we need to find the measure of these angles. So I'd like for you to work on number 8 real quickly. Pause the video, solve that, and then come back, check your work. All right, let's see how you did. We need angle 1. We have very little information about this triangle at all. We do have a vertical angle here, so I know what this one is, and I know what that one is. We could do it that way. Or I have one angle congruent, I've got another angle congruent, which means this angle is also going to be congruent to angle 1, so I could do it like that. Either way. So let's see here. We're going to use the triangle sum theorem, which says that all three angles add up to 180 degrees. So first, I'm going to take 46 plus 54, and that equals 100. And I'm going to take that and subtract it from 180. So 180 minus 100 gives me 80 degrees. So y is 80 degrees. And since this works for the third angles theorem, I know this angle is congruent to that angle. And so the measure of angle 1 is also going to be 80 degrees. All right. Okay, so we had a couple of theorems here, a little bit of stuff. Important things to pay extra close attention to. The order that you list your vertices in the congruent statement has to match. Okay, they have to be in the same order. Congruent vertices have to go together. All right. Next, you have to have all of the pieces of one shape, whether it's a triangle or a quadrilateral or whatever it is. All of the corresponding angles have to match. All of the corresponding sides have to match. Okay. And finally, third angles theorem. If you have two angles in one triangle going to two angles in the other triangle, that means that the third set of angles is also going to match. It does not mean the triangles are congruent, but it does mean that those third angles are going to match. So I hope this helped. I hope you found it useful, and I will see you next time.